Now I'll walk you through the this tutorial and then fill in the missing pieces. In order to do this tutorial, we'll use the Cloud9, which is an IDE environment that is heavily integrated with AWS services, and that helps us hit the ground running right away um, without any further configurations. And so I just update the node instances right here. And then do this, clone the project, all of this, install the dependencies. While that's going on, we'll look at the config file. And so here is the config file. So we need to specify what S3 bucket we want to put the code and all the assets in. And then this is just configuring the name for this project and the default region. And so we have to create an S3 bucket, so let's do it. BYOD test with my name so that there's no name collision. Then copy this name and versioning, actually, yeah, create bucket. And so once the bucket is created, we copy the name of the bucket into this. And so all the assets will have the name BYOD with the dev prefix. And then, okay, so we are using root, so there's no AWS credential to configure. And then okay, so now we're ready to start the tutorial. We need to configure the mock directory, and so this mock directory is mimicking what your container will see when it's being built. So for training, the directory that will be available in SageMaker will start with /ops/ml, and then it will have the two subdirectories input and model. So the structure is shown right here, and then we will initialize the directory using this. And so we'll see what the train init script does. And so it's actually creating these files. So hyperparameters.json /ops/ml/input/config/input data config. So yeah, and then resource config, and then the model. So these are the files that will be created. So we go ahead and we put this in. So now you see that the input folder has the files that we have created, and so the data config is just saying that this is a configuration for the training, and then the hyperparameter is just the key value that will be used to train the model. It will be combined with the input value, and then resource config like this. So okay, so then we edit the hyperparameters to say that this is test and x equals 1. And here we're telling the project that for training we are getting JSON files. So we go to input data config, and yeah, so this is actually already configured, but we'll do it again just to make sure. And so train.json would be the data that you want to train it on, and so the hyperparameters are configurations of the model, and the data is our input data. So train.json here. Okay, so now with the training code, we see that train.py. So actually, this is an example of this repository has an example of your training, what your training image should look like. So it's copying from the base image, mxnet, and then the entry point is this. So when SageMaker execute this container, it will call Python user bin python3 and then /op/program/train.py, and so we would have a file called train.py, which we are configuring here. So containers train code train.py, and this will take the input data and produce the along with all the configurations and produce the model artifact. And so let's look at what the code is doing here. It's taking the hyperparameters.json file, which in the mock directory is this file, and which only has x equals 1 in the name. And so the result is just the x value of the hyperparameters times the data in the train, which is y equals 2. And so that would just be 1 times 2 is 2. And so the model would return the result with a name called test, like as a JSON, and yeah, so that's the name, and then the result will be 2. And so yeah, and then print the model, outputting the model into this JSON file in the /ops/ml/model/model.json file, and the serving image will take this model and then serve it at endpoints. So this is the extent of our training script, and this is just a proof of concept, but it shows you how you can see how this can be extended to much more complicated models where you specify the hyperparameters for the models, so like different things that the configurations of the model, and then you have the train, and like with the input data, you can say what type of data it is, what format it is, and it will be taken care for you. So that is the extent of the training image creation.